All right, another set of AP problems. I call these area collector problems, and we're generally asked to try to find some total in the end. And we look at this train problem. Train A runs back and forth on the east-west section of railroad track. Train A's velocity, measured meters per minute, is given by this differentiable function. T is measured minutes. Selected values are given in the table. Find the average acceleration of train A over the interval 2 to 8. Am I given position, velocity, or acceleration? I'm given velocity. It's asking for acceleration. Is it asking for instantaneous acceleration or average? So if I want to find average acceleration, what will I find? Just the slope. That's all I have to do. So because acceleration is the rate of change of velocity, I will do a slope formula. And so we're going to find v of 8 minus v of 2 all over 8 minus 2. What is v of 8? Negative 120 minus 100 divided by 8 minus 2. And I get negative 220 divided by 6, or negative 110 over 3. What is my label? Meters per minute squared. Is that a point that people could get? Yeah, we can get that point. Let's look at B. B says, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time between 5 and 8? So from here to here, does it have to have a velocity of negative 100 at some point? Why? Okay, so we're saying some really good things there. We have to put it in a right format so that they understand it. We're going from 40 to negative 120, and negative 100 is between those values, correct? Okay, great. Now, it doesn't have to cross over negative 100 if it's not continuous. But this is continuous because it's differentiable. What theorem guarantees that if we go from 40 to negative 120 that we have to cross over negative 100? What theorem? Intermediate value theorem. So this is a very important time where you have to invoke the IVT. First of all, we say, it says, do the data support? Yes. So negative 120 is less than negative 100, which is less than 40. So by the IVT, and you don't have to state intermediate value theorem, you just write IVT, there must be, and what it says, a time between, what is it, 5 and 8? So 5 less than or equal to t, which is less than or equal to 8. So there's a time between 5 and 8 such that the velocity is equal to negative 100 meters per minute. Now, one thing that the AP exam might like you to write, even more than this negative 120 and 40, is they might like you to write, say, V of 8 and V of 5. But I think as long as you include that negative 120 and 40, since it's up in the table, you're fine. You're good to go. We all good there? All right, I know you can get the first part of problem C as well. It says at time P equals 2, train A's position is 300 meters east of the origin station. The train is moving to the east. Write an expression involving an integral that gives the position of train A in meters at time 12. So I want to state position. Position is equal to, what have we said all along? Start plus displacement. Where does it start? $300 plus, how would I write the displacement? Integral 2 to 12 v sub a of t dt. So they have train A, so that's where we write v sub a. That's our position. It now wants us to find the position, and it wants us to use a trapezoidal sum. Did I teach you guys how to do right-hand sum, left-hand sum, midpoint sum? Did I teach you how to do trapezoidal? Yeah, we simply average right and left, didn't we? But it's different in this scenario. And the reason why it's different is because when we were doing it, the widths were all exactly the same. Now they're different. You can see that we have 3, 3, and 4. So we can't simply average them. It won't work. Okay? So here's what we're going to do. We're going to actually make a trapezoid. There's no other easy way around it. So I'm going to make a trapezoid. I have a height of 100, and I have a height of 40. And I have this bottom part of 3. You see how I came up with that shape? Exactly. Everybody okay with how I came up with that shape? So, if that's my shape, what's the area of a trapezoid? What's my formula? Okay, so in this situation, I have 1/2. What is the height in this shape? 3. What's base 1? Base 2? There's no calculator on this problem. So we're going to have to work this out and be very careful. We have 300 plus, we have 1/2 times 3 times 100 plus 40. Let's do the next trapezoid. What are you going to call the height of the next trapezoid? So I just did from 2 to 5, so now I'm going to go from 5 to 8. So 3. What's the height of one side, or what's the base of one side? 40. What's the other base? Negative 120. Yep. Then we're going to go from 8 to 12. Yes, exactly. Yep. And then we have 1/2 times, what's the last 4? And we go from negative 120 to negative 150. What we got? Okay. So no calculator on this problem. So no easy way about it other than just doing it. 300 plus, what's 100 plus 40? Times 1/2. Times 3? Good. 40 and negative 120. Negative 80 times 1/2. Negative 40 times 3. And negative 120 and negative 150. Negative 270. 1/2 times 4 is 2. 2 times negative 270. Negative 540. So it looks like here we have 6, or nope, that's 510 minus, this is 660. Negative 150 meters is its placement. So it's 150 meters to the left of the origin train station. Okay? Last part, D. A second train, great, train B, travels north from this station. Time t, the velocity of train B is given by this function, so that's a velocity function. And at time 2, the train is 400 meters north of the station. Find the rate at which the distance between the two is changing at time 2. Ooh. Origin. We have a train headed to the east. We have a train headed to the north. This is train A. This is train B. And we are wondering at time 2, whoop, my smartboard is freaking out. We're wondering at time 2, what is their distance apart changing at? So I've got to draw one more piece here as soon as my smartboard comes back. I'm wondering the rate at which their distance is increasing. All right. How far east is the first train at this time? $300. How far north is the other train? 400. I'm going to write an equation that relates these pieces. So we're going to find out how far apart they are now using the Pythagorean theorem. Oh, the 300, 400 from the previous part. Yep. So part C tells us the 300. So I have e squared plus n squared is d squared. Everybody agreed? What's the derivative of e squared with respect to time? 2e, e prime. Remember this type of problem? Plus 2n n prime equals 2d d prime. How far east? So 2 times 300. What is the rate? Look up at your chart. 100. How far north? 400. How do I figure out the north rate? Yeah, I'm given this formula here. It says the velocity is equal to -5 t squared plus 60t plus 25. So if we plug in 2, that will tell us the rate. So 2 squared is 4 times -5 is -20. 2 times 60 is 120 plus 25. What do I get? Yep, 125. And then Caleb said that this is a special right triangle. It is a Pythagorean triple. So what's D? 500. Now, since I don't get a calculator, I'm going to do some fancy mathematics. Can I just divide through by 2? Can I also divide through by 100? So we're going to get 300 plus 2 times 4 times 125 equals, well, the 2's gone. Never mind. 4 times 125 is equal to 2 is gone, so 5d prime. So 300 plus, what's 4 times 125? 500 is equal to 5d prime, so 800 equal to 5d prime. 800 divided by 5, 160 meters per minute. And that's the answer. A lot of mathematics covered there, right? Brings you back a little bit to first semester, related rates. All right, go get some brain food and come on back. All right, YouTube Nation, we just got done talking about cysts, and we got some good ideas, so cool. All right, here we go. Let's do a problem regarding Johanna. Johanna jogs, 15 minutes, ready, set, go. Jogs along a straight path for 0 to 40. Johanna's velocity is given by a differential function, yada, yada, yada. So this one's actually easier than the last one. So let's see if we can get all of this together and not really have any issues, okay? We got problem A, and problem A says use the data in the table to estimate, excuse me, smoker's cough, V prime of 16. I've got, this is V. I want to find V prime of 16. I want to approximate it. Come on, you guys are the best of the best. So V prime would mean acceleration, the derivative, right? And am I finding the exact value or an estimation? So I will use a slope formula, and 16 falls right there, right? So would you say that V prime of 16 is approximately V of 20 minus V of 12? Divided by 20 minus 12? That sound reasonable? So what's V of 20? 240 minus V of 12? 200 divided by 8. And I get 40 over 8, which is 5 meters per minute squared. Now, just to be clear, somebody first hour said right away, they're like, well, it's 220. I said, well, good. I said, how'd you come up with 220? They're like, well, you just look at it. Well, 220 is the average value between 200 and 240, but you have to divide it by the passing time as well. So it doesn't work out just like that. So you got to be very careful, okay? Problem B. This is one I expect everybody on the AP exam to get problem B correct. It says, using correct units, explain the meaning of the definite integral 0 to 40 absolute value of V of t dt. What is that? Total distance. Good. Now let's make sure we can get all the points, because this is where I got a couple points wrong when I was first trying these problems. That integral represents the total distance in, what's the measurement? Meters. Johanna has traveled from time equals 0 minutes to time equals 40 minutes. So absolute value refers to that total distance. 0 to 40, those are the time, and you must express it in minutes, and then distance in meters. So make sure all those pieces are there. Yep. But now it asks me to actually calculate it, doesn't it? It says use Right Riemann Sum. Well, Right Riemann Sum is easier than trapezoidal, isn't it? So let's approximate that using Right Riemann Sum. So I have 0 to 40 of absolute value V of t dt. So what's the width of the first rectangle? 12. And if I am going to go to the right-hand side, what's the height? 200. Plus, what's the width of the next rectangle? 8. And what's the height? 240. What's the next width? And what's the height? Negative or positive? Which is it? Why is it positive? Absolute value, so 220. If we did negative, that would give us the displacement, but we're looking for the total distance. $16 times what? 150. Okay, no calculator on this problem, it says. 12 times 200 is 2,400. 8 times 240. Well, sometimes you just maybe need to do this. 240 times 8. 0, 32, 3, 16, 19, 19, 20. So I got those two done. That's 880. And then 150 times 16. 0, 30, 9, 0, 1, 5, 1 plus 0. Whoop. That's not. What did I? Shut up. That was 0 right there. 0, and then this is 4, 1, 2, 2,400. Sorry, YouTube. I normally don't tell my students to shut up, but one of them, whose name will remain unnamed, was making fun of me. So, anyway, I got 4,800 plus 1920 plus 880. So 0, 0, 1, 10, 16, so 6, 2, 7, 7,600 meters. Sweet. What? That's the total distance traveled. So that is 4.5 miles. Well, 6,400 meters is 4 miles, because 1 mile is approximately 1,600 meters, just off by a couple feet. So yards, that would be 1,760, I think. Oh, we're not done with the problem. Okay, so we did part. Was that just part B? Holy cow! How much time do you think we have on this test? All right. Part C says Bob is riding his bicycle along the same path. Great, now we got Bob. Bob's velocity is modeled by this. So this is a velocity function. T is measured in minutes, and B of t is measured in meters per minute. Find Bob's acceleration. I think everybody should be able to get this problem right on the test. If we plug in 5, that will give us velocity. We want derivative, so I say acceleration at time t is equal to b prime of t, which is, what's the derivative of that function? 3t squared minus 12t. And at what time are we looking for it? So a of 5 is b prime of 5, which is 3 times 5 squared minus 12 times 5, or 25, 75 minus 60, 15 meters per minute squared, because it's acceleration. I think everybody could get that problem right on the test. Is that fair to ask that? Okay. All right. Thank you for your input. All right. Last question. It says, based on the model B from part C, so based on this guy right here, find Bob's average velocity during the interval 0 to 10. Average velocity. Are we given his velocity function? So we're wondering the average value of that function. Do you remember the formula for average value of a function? Now, when you see the word average, a lot of times you think of your slope formula, okay? If you're looking for a rate of change, then you would look for the slope formula. So if it asks for his average acceleration, then we would use the slope formula. But we're given the velocity function. And since we're given the velocity function is asking for average velocity, we have to find the average value of that function. Does that kind of make sense a little bit? If it was average acceleration, that's a rate of change from your velocity. So you'd use slope. But average velocity, average value of that function. So we've got to set that up. So that's our formula for average value of a function. So integral from what? 0 to 10. So I have 1 over 10 then here. What's my function? T cubed plus 300 dt. Really? They expect us to do it by hand? Unbelievable. 1/10 times, what's the antiderivative of t to the third? 4th over 4 minus. Yep. Sweet. Okay. Yep. 10,000 divided by 4. 2,500. 10 cubed is 1,000 times 2 is 2,000. Plus 3,000. Plug in 0, you get 0. 2,500 minus 2,500 plus 3,000 is 3,500. So 1/10 of 3,500 is equal to 350. What's it asking for? Average velocity, so meters per minute. That was easier than the first one, wasn't it? Okay, so I'm going to give you what I think is, pretty straightforward when you've seen the other two. We just did problem 3. I want you to work on problem. Oh, looks like I have 2 4s written down. That was stupid. Way to go against. Do number 5, which is problem number 3 from 2013. That would be an excellent problem for you guys to work on in context of what we've just done today. You can put it there, that's fine. This isn't a homework problem. This is just something that you should do. You won't turn that in, but you should do this and score yourself. We're going to go over this one tomorrow. Again, this is your time. This is where all of a sudden you say, how much do I want to be that person who scores a 3 or a 4 or 5 on the AP exam? Okay? And so I know earlier this when we talked about that, everybody was said we want to do it. Right now it's like, okay, I'm tired at the end of the year. Do I really care? Well, find it. Yes. So the 2 that you did, you should have done 2 last week Friday, and that's on a separate sheet of paper. But we're just going to show you all the work and the answers in class on this tomorrow. But you should try it on your own and try to get 100%. If you can't get 100, try to get 3 out of 9. Get the points where you can get them.